determine a common denominator in order to add and subtract. So same rules. If they're common, you can add them. You add just the numerator, or you subtract just the numerators. Okay, so the hardest part is coming up with the common denominator. So what would the common denominator be between b and b plus 7? 12. These are the denominators. Yeah. So b plus 7, no. B, no.
C squared.
B times b plus 7 would be the common denominator. Because there's nothing that both go into, right? B doesn't go into b plus 7, and b plus 7 doesn't go into b, right? So then you'd have to come up with multiples that they both go into, and there's nothing until you actually multiply the two together. Okay, how about the next one? Well, the first thing, in order to do this, we might want to factor this trinomial to see it a little better. And so what would this be factored to be? Okay. Does everybody see this would be factored to be that? So what is my LCD? I hear x plus 2. Okay, so they both have to be able to go into. Can this go into x plus 2? No. It should be x plus 2 times x plus 2. So I'll just do squared. Okay, I'll go over an actual number thing, because so for instance, if the denominator was 6 and 12, what would the common denominator between 6 and 12 be? 12. So you got that right away, but you were having trouble with this. This is like saying the x plus 2 is 6, and the x plus 2 times x plus 2 is 12. Do you see what I'm saying? They both have to go into the common denominator, not the other way around. Sometimes people get confused with GCFs, right? And LCDs. Okay, so let's do this one. So let's factor this. What do we get here when we factor? Y plus 2 times y plus 4. Yes? What does this factor to be? Y squared minus 4, what does that factor to be? Yeah, y minus 2 times y plus 2. Okay, so what is the LCD going to be? What do they both go into? Y plus 2 is a common factor, it's not the LCD. They all have to go into it. Okay, the LCD would be y plus 2 times y plus 4 times y minus 2. They all have to go into, so think about this for a second. Y plus 2 times y plus 4, you would have to multiply it by y minus 2 to get that denominator. Y minus 2 over y minus 2. With this one, you'd have to multiply it by the y plus 4 in order to get it. You can't say, oh, well, there's a y plus 2 that's both common. How would I get rid of a denominator? You have to go into the bigger number, right? Okay. Back in grade 10, just so you know, and I don't know how you guys learned this, LCDs and stuff, you'd have, say you had 12w squared and, I don't know, say 24wy, and you had to find the LCD between that. It seemed like you had no troubles doing that from the previous lesson. But this is how you learned it in grade 10. You were supposed to do prime factorization. So it would be 2 times 3 times w times w. Remember doing this in grade 10? And then here you go 2 times 2 times 2 times 3 times w times y. Then you'd circle the common ones. So then you'd have that and that and that. And the common ones was the GCF, right? So that would be, for instance, the GCF would be 12w. Okay? But the LCM is the highest power of each of the factors. So it would be 2 to the power 3 times 3 to the power 1 times w squared y. I'll write that out just in case. So the GCF is the circled one, so that would be 2 times 2 times 3 times w, which is 12w. That's the GCF. The LCM, or we're talking about LCD, it doesn't really matter, is the highest power of each of the factors. So it would be 2 to the power 3, because there's 3 2's there, 3 to the power 1, w to the power 2, and a y. So that ends up being 8 times 3 is 24 w squared y. That would be so for instance, you'd have to multiply the top one by 2y and the bottom by just a w. Okay, so when I'm doing it over here, although I have a y plus 2 that's common, that would only be, you'd only use one of them, and then you still need each one if you kind of extrapolate it to that point. Okay, so once you do this a couple times, it gets pretty easy. Okay, my projector's going. So what would this be factored to be? So first off, you need to take out a 2, and then you're left with t squared minus t minus 2. And does that factor? Does that factor? Yeah, t minus 2t plus 1. Yes? Okay, this one, what's a GCF I could take out of that one? A 2, and then I'm left with t squared minus 3t minus 4. And then what does that factor to be? T minus 4 t plus 1. Okay, so now I'm just going to underline the common ones, just like I was doing over there. So I have a 2 that's common and a t plus 1 that's common. So now what would my LCD, remember they all have to go into? Very good. Again, the ones that are common, you'd only have one of them. You don't represent them twice. And then you have to have the other ones in there because they all have to go into that. So I'm going to give you a second to do E and F now that you're kind of getting it. Hopefully. Yeah. Okay, try. So this factors a 2 out. Oh, that's a little too large. And I'm left with x minus 2. This is a 3x squared minus 3x minus 4. 3x minus 4, x plus 1. There is nothing common, so they all get multiplied together. Some people forgot to multiply the 2 times 3. So the LCD would be 6, x minus 2, x minus 4, x plus 1. Yes? Okay, this factors to be x minus 6, x plus 6. This, people factored out an x, and you're left with 6 minus x. It looks very similar. What was the little trick I showed you? The minus 1 trick. So this becomes negative x, and then this becomes x minus 6. Multiply it out. See if you get what that is, just in a different order, right? Negative x times x is negative x squared. Negative x times negative 6 is positive 6x. You see I didn't change anything? So now I have a common factor of x minus 6. So what's my LCD? Negative x, x minus 6, x plus 6. Everybody good? Alrighty. Moving on, now we're going to start adding them. So what's the LCD between 2x plus 1 and x plus 2? What's the LCD? Huh? Yeah, just multiply the 2 together. 2x plus 1 times x plus 2. Everybody see that? There's nothing common between those two factors, so it's just going to be the 2 multiplied together. So now we need to multiply both fractions by a form of 1 using the LCDs. Multiply each fraction by what you are dividing from the LCD. Okay, so 2 over 2x plus 1 I need an additional, do you see x plus 2 on the bottom, right? So I can't just do that. So I'm multiplying by an x plus 2 over an x plus 2, the form of 1, which means I'm not changing the fraction. Plus 5 over x plus 2. Does everybody see? In order to have that LCD, I need to multiply the bottom by a 2x plus 1. Can't just do that, so I multiply the top by 2x plus 1. So I get my form of 1 there. Are we good? Okay, so now I'm going to multiply the top. So 2 times x plus 2 is a distributive property, so I'm going to get 2x plus 4 over 2x plus 1 x plus 2. I'm not going to actually multiply that. I'm just going to keep it like that at the bottom. Plus, now I'm going to multiply these two. 5 times 2x plus 1, distributive property. I get 10x plus 5 over x plus 2, 2x plus 1. Now when you're multiplying, it doesn't matter which order you have it. They are exactly the same. So now I'm going to put it all over 2x plus 1, x plus 2. Watch the signs. If you're subtracting, I would highly recommend changing the subtraction into an addition and switching the signs of the binomial or the trinomial, because a lot of times people make mistakes otherwise. So let's multiply this together. 2x, multiply together. Add it together. 2x plus 10x is 12x. 4 plus 5, 9. And you might say, oh, there's a common factor you could factor out. You could try to see, but this is all, it's all good to go. Okay, so bada bing, bada boom, we're done. State my non-permissibles. X cannot equal. What can it not equal? It's not 0, people. -2 and -1 over 2. Thank you. Set those factors equal to 0 and solve. Hopefully it's a mental math question. Scroll up. Okay. Do you guys want to try these? Yeah, let's try them. Let's do it. Okay, so this is factored to be x plus 3 times x plus 2. So my LCD is x plus 3 times x plus 2, which means I don't have to do anything to the second fraction. So the first fraction is over x plus 3, so that's going to be x plus 2 over x plus 2 plus 3 over x plus 3, x plus 2. Does everybody see that? I need to multiply this together. So I get 2x plus 4 over x plus 3. Make sure you have brackets around the x plus 3, x plus 2 at this point. Plus 3. And so then my final answer becomes 2x plus 7 over x plus 3, x plus 2. Where x cannot equal -3 and -2. Yeah? Okay. This one, when I factor this one, it's going to be y minus 4, y plus 4. Looks very similar to the 4 minus y. So if I rewrite this as the -1 trick, again, check, multiply negative times y is negative y, which is that. Negative times -4 is positive 4. Now, does everybody see here the negative, and maybe I need to write this again, but the negative, what happens when you have negative? You get a positive. So, this is y, and I'm just going to rewrite it so you can see that. Y minus 4, y plus 4. Subtract 4 over -y minus 4. It doesn't matter where you stick this negative on top, beside, but either way, this negative makes a plus. So that was what you had to know. So what's the LCD? The LCD is going to be those two multiplied together. So that means I need to multiply this one by y plus 4 over y plus 4. So I get y over y minus 4, y plus 4. It's a lot of writing at this point. plus 4y plus 16 over y minus 4, y plus 4. So I get my final answer? 5y plus 16 over y minus 4, y plus 4. Y cannot equal plus or minus 4. Yeah? Do we have another page? Oh yeah, keep going now, keep going now. Okay, this factors to be m plus 3 times m plus 1, and this is m plus 4 times m plus 3. So that is common. So 2 over m plus 3, m plus 1, and then I got to multiply this by an m plus 4 over m plus 4. Plus 3 over m plus 4, m plus 3. I have to multiply that by m plus 1. Oops. So then I get 2m plus 8 over m plus 3, m plus 1, m plus 4 plus 3m plus 3 over m plus 4, m plus 3, m plus 1. So I get 5m plus 11 over m plus 3, m plus 1, m plus 4. M cannot equal negative 3, negative 1, negative 4. Did you get that one for C? A minus 5, A plus 5. This one is A minus 4, A minus 5. So my LCD is going to be A minus 5, A plus 5, A minus 4. So A over A minus 5, A plus 5 times A minus 4 over A minus 4 plus 2 over A minus 4, A minus 5. So I'm going to multiply this by A plus 5 over A plus 5. So then I get A squared minus 4A plus 2A plus 10 all over A minus 5, A plus 5, A minus 4. So my final answer is going to be A squared minus 2A plus 10 over A minus 5, A plus 5, A minus 4. A cannot equal plus or minus 5 and 4. Yeah. We're out of time here. So this is 2y minus 3, 2y plus 3, and then this would be 2y minus 3 times 2y minus 3. So you got to make sure that you have all of them indicated. So because these are 2, it's the highest power of it. So the LCD would actually be 2y minus 3 times 2y minus 3 times 2y plus 3, just so you know. Or you could just square. That's actually, my hand is getting sore from writing so much, so I'm actually going to put a square because that's a little bit. The other thing I would say is don't take the subtraction. I would make this a plus and a minus so that you know when you're multiplying what to do there. So 3y over 2y minus 3 to y plus 3, and that's going to be multiplied by a 2y minus 3 over 2y minus 3 plus minus 2y over 2y minus 3 squared. So that's going to be multiplied by 2y plus 3 over 2y plus 3. Yes? So then I get 6y squared minus 9y minus 4y squared minus 6y all over 2y minus 3 squared 2y plus 3. So then I get 2y squared minus 15y, yes? Over 2y minus 3 squared, 2y plus 3. Y cannot equal 3 over 2 and minus 3, plus or minus 3 over 2. That's the easiest way of doing it. Okay. Did you get it right? Because the subtraction might have confused people, right? Okay, this one would be y plus 2, y minus 1. So this is y plus 1 over y minus 1 times y plus 2 over y plus 2. Yes? Plus y minus 1 over y plus 2, y minus 1. So does everybody see the first fraction, there's a FOIL? First, outer, inner, last. That's why I put this one on there. So you get y squared. Outer you get plus 2y. Inner you get plus 1y. So plus 3y plus 2 plus y minus 1 over y minus 1, y plus 2. Notice I'm not doing that intermediate step where I write them individually as fractions. I'm now putting them all together. It's just less writing. So y squared plus 4y plus 1. Yes? Over y minus 1, y plus 2. Y cannot equal 1 and negative 2. Did anybody get that answer? Okay, there's more. This is a minus 1 times a plus 1. This is a plus 1, the whole thing squared. This is getting crazy now, hey? I like the last question though. You should try that one, and we'll go over it tomorrow if we run out of time. So a plus 2 over a minus 1, a plus 1. We need an a plus 1 squared though. So that means I need to multiply the top by an a plus 1. I'm skipping steps now. Are you getting to that point? So a squared plus 3a plus 2 plus a squared minus 2a plus 1 all over a plus 1, the whole thing squared, a minus 1. So you get 2a squared plus a plus 3 over a plus 1 squared, a minus 1. A cannot equal plus or minus 1. Okay. This will be 2z plus 5, 2z minus 5. This would be 2z minus 5. 5, 2z plus 1. Is that what it is? Let me see. Let's see if that works. Yes, that will work. So my LCD is 2z plus 5, 2z minus 5, 2z plus 1. I always put a line in the z's because it gets mixed up with 2's otherwise. 2z minus 1. I don't know why I put it in a bracket. So let's try this again. 2z minus 1 over 2z plus 5, 2z minus 5. And then we're going to be doing 2z plus 1 over 2z plus 1. So it's a FOIL on top. Plus 2z plus 5 over 2z plus 5, 2z plus 1. Oh, this should be a minus, shouldn't it? So then this is a 2z plus 5 over 2z plus 5. Yes? Yes? So, we get 4z squared. Outer we get plus 2z. Inner we get minus 2z. So then we just get minus 1. This one we get plus 4z squared. Outer we get 10z, inner we get 10z, so we get 20z plus 25. All over this whole concoction of z's. So my final answer is 8z squared plus 20z. Why? Plus 24 all over 2z plus 5, 2z minus 5, 2z plus 1. What do you think about that? Okay, I'm going to do top. So, no, you know what, that's not going to work, eh? Okay, so top is n squared plus 4n minus 3 over n minus 4n plus 4 plus 4n minus 3 over 3n minus 4. So this has to be multiplied by a 3 over 3, and this has to be multiplied by an n plus 4, n plus 4. So then I get 3n squared plus 12n minus 9. This is a FOIL now, hey? So first I get plus 4n. Okay, so maybe I'll just write it out. So plus 4n minus 3n squared. Outer I get plus 16. Inner and last I get minus 12n. All over 3n minus 4n plus 4. So the 3n squares cancel, and the 12n cancels. That's kind of nice. So then you're left with 4n plus 7 over 3n minus 4n plus 4. So then I'm going to do the bottom. The bottom is n minus 4, n plus 4, plus 1 over n plus 4. I gotta scroll this up here. So that's going to be multiplied by n minus 4 over n minus 4. So this is going to be n plus n minus 4 over n minus 4, n plus 4. So then I get 2n minus 4 over n minus 4, n plus 4. So top divided by bottom. So 4n plus 7 over 3n minus 4n plus 4 divided by 2n minus 4 n minus 4 n plus 4 or n plus 7 over 3. My hand's getting sore at this point. N plus 4 times n minus 4 n plus 4 over 2n minus 4. Cancel, 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 cancel. Looks like I get 4n plus 7 over 3 bracket 2n minus 4. Well, you can multiply it in if you want. N cannot equal, you got to watch, you cancel some stuff now, right? So these ones were there, so plus or minus 4 has to go back in, and in grade 12 that's what I would write, because you can actually read that already. Yeah? So that's just a 2 then, right? There's your final answer.